Here's a statement. The square root of x is y such that y times y equals x. That sentence is 100% true. It's also 100% useless to a computer. Today we'll uncover why true statements aren't enough, and what every algorithm actually needs to work. Recipes, not facts. That's the hidden anatomy of computation. Two kinds of knowledge live in the world. Declarative knowledge describes what is true. A cake is a sweet-baked dessert. The square root of 16 is 4. These are facts, statements, definitions. Imperative knowledge describes how to do something. Preheat the oven, mix the flour, fold in the eggs. Start with a guess, check it, refine it. Computers cannot use facts directly. A definition tells a machine what the answer looks like, not how to find it. Computers need imperative knowledge, they need recipes. Let's anchor this with cake. The sentence, a cake is a sweet-baked dessert, won't feed anyone, but a recipe will. Combine 2 cups of flour, 3 eggs, 1 cup of sugar. Bake at 350 degrees for 30 minutes. That's imperative knowledge in everyday life. Programming is exactly this. Programming is writing recipes precise enough for a machine to follow. And here's the thesis of this whole course. An algorithm is a recipe, nothing more, nothing less. Every algorithm, every single one, has exactly 3 parts. First, a sequence of steps, instructions executed in order. Second, a flow of control, decisions that determine which step runs next or how many times. Third, a termination condition, a rule that says when to stop. Miss any of these 3 and you don't have an algorithm, you have a fragment. Keep these 3 bones in mind. We'll find them in the square root method and again in the cake recipe. Let's build a real algorithm to find the square root of 16. Our recipe uses one update formula. The new guess equals the old guess plus x divided by the old guess, all divided by 2. We also need a tolerance, which we'll call epsilon, set to 1. Here's the stopping rule. Stop when the guess squared is within epsilon of x. Let's start with a guess of 3. 3 squared is 9. 16 minus 9 is 7. 7 is bigger than 1, so we keep going. Now let's compute the new guess. 3 plus 16 divided by 3 equals 3 plus 5.333, which gives 8.333. Divide that by 2 and we get 4.1667. That's our iteration 2 guess. Square it. 4.1667 squared is 17.361. Compared to 16, we're off by 1.361. That's still bigger than epsilon, so we refine again. Take 4.1667 plus 16 over 4.1667 divided by 2, and we get 4.0035. Square that, 16.028. Now we're off by just 0.028. That's less than 1, so we stop. Notice the answer isn't 4, it's 4.0035. Close enough is a legitimate stopping rule. Algorithms often approximate. Now find the 3 bones. The sequence of steps. Guess, square it, refine. The flow of control, the if not close enough, otherwise stop decision that loops us back. The termination condition, the absolute value of guess squared minus x being at most epsilon. Each iteration is one pass through the recipe. We did 3 iterations and the loop stopped exactly when the rule said to. Back to the cake, the numbered steps, mix, add, bake, those are the sequence. The line, if no egg, use a 1/4 cup of applesauce. That's flow of control. A decision that changes which step you take. And the toothpick test. Insert a toothpick. When it comes out clean, remove the cake. That's termination. Same 3 bones. Square root, chocolate cake, GPS routing, Google search. Every algorithm wears the same skeleton. Steps, control, stop. Zoom out. Google search ranks billions of pages. Steps, control, stop. GPS routing finds the shortest path. Steps, control, stop. A neural network learns from data. Steps, control, stop. The rest of this course teaches you to express recipes precisely enough that a machine can follow them. You'll learn variables, conditions, loops, functions. But underneath, every program you write is a sequence of steps, a flow of control, and a way to know when to stop. One last truth. Understanding this video is not the same as being able to write code. Programming is a skill like cooking or playing piano. You don't get it from watching, you get it from doing. So here's your assignment. Open an editor, type out the square root algorithm, run it with x equals 16, then try x equals 2 or 25. Watch it converge. You cannot learn to cook by watching cooking shows. You learn by burning a few cakes.